Hi guys, if you have questions, email me or write a comment. After we have explained optimization problems with first example, now let's try to solve another example on this topic. Let's try to read it together and keep in mind that to understand word problems, you need to be able to solve it, you need to read it at least 3 times in order to understand every point in it. So let's read this together. A manufacturer wants to design an open box having a square base and a volume of 32 cubic centimeters. What are the required dimensions to use the minimum amount of material? Of course, as a manufacturer, this is important. The amount of material will affect the amount of money that you need to spend. So if you are required to produce such a box with such a volume and you know the volume that you need, so you have to take care about the material. You can't just do any box with any dimension because this may affect the cost. So let's go to the steps of solving such problems. As I said, the key is to look at the sentence that contains the extreme value. In this case we have minimum. So minimum amount of material is my key. So the first thing should be writing that sentence, minimum amount of material. Okay, the minimum amount of material. The second step was to make a drawing of the problem if possible. In this case we have a box, so let's try to draw a box. Well, I'm not a good drawer, but let's say that this is our box. And what was mentioned about the box here? It was mentioned that should be an open box, so it has only one base, and design open box having a square base. So the base should be square, which means I'm talking about x by x, and let's say that this is the height, which is y, and one of the bases is there, so one of them is not included. So I'm talking about an open box. So minimum material. Now minimum material should be the sentence that gives me the formula that I can relate dimensions. Minimum material means the area or the surface area of this box. So surface area will be equal area of all faces. In this case we have one base, which is x by x here, so x squared plus area of the other 4 faces. The other 4 faces will be x by y, this face, and the same thing will be repeated, x by y for this face. Okay, same thing for other faces. So we have 4x by y, 4xy. Now we have a relation, that relates x and y, but unfortunately it has 2 unknowns, 2 variables. And as I mentioned in the other video and explanation, you need to make this formula depends on one variable only, so either x or y. How am I going to do this? Either from the drawing we can find the relation, or from the question itself. Here it says a volume of 32 cubic centimeters, so the volume is known, which means I can use the volume as a secondary equation. The volume is equal to length by width by height. So volume, which is 32, is equal to length by width, so x by x, that's x squared, by the height, which is y, so it's x squared y. Now we need to solve it for either x or y. Let's have a look at our relation here. We have both x and y. Which one is easier to replace? I believe y is easier, since we have only y here. So let's solve it for y. This means y equal 32 over x squared. This is my secondary equation. Now let's apply it to our relation here. So a will be equal to, you can call it a or f, whatever, x squared plus 4x times y, which is 32 over x squared. Now let's simplify this. Let's simplify it. So it's x squared plus 4 times 32, that's 128. With x squared, that will give you over x. This is a, now we need to derive it. So a prime equals, the derivative of x squared is 2x. The derivative of 128 over x, that's a constant over function, so it's negative the constant, times the derivative of the function over the function squared, or you can apply the quotient rule, whatever the rule that you know, or you can take x up, make it to the power of negative 1, and then derive. Now, next step is to make it equal 0 in order to check for maximum, minimum, the extreme value. Solve this for x. So this will give you 2x equals 128 over x squared. When you multiply by x squared and divide by 2, you will get x squared equals 64, which means, x cubed equals 64, which means x is equal to third root of 64, which is 4. Now, next step is to check for, would it give you maximum or minimum? And keep in mind that we are talking about a box here, so the value of x can never be less than 0 or 0 itself. So 0 is an open circle here, it's not included. Let's check the sign of a prime. Let's choose value less than 4, let's say 1, and here is my derivative. 2 times 1, that's 2, minus 128, that's negative. Anything greater than 4, let's say 5. 128 over 25, that's about 5 point something. 2 times 5, that's 10, minus something less than 10, then that's sure positive. You can use a calculator, of course, for that. So negative means decreasing, positive means increasing. So here we have a minimum value. So x equals 4 will give you a minimum value. What about y? Y, you can find it from this relation here. So 32 over 4 squared, and that will give you 40 over 16, which is 2. So dimensions of the box should be 4 by 4 by 2. This will give you a volume of 32 and the minimum amount of material used. So if you are the owner of this factory, this is how you should produce a volume of 32 centimeter cubed with a minimum amount of volume. I hope that this was useful and you got the idea. Good luck. Remember to like, share, and subscribe, and write your questions via email or comments.